Chapter 7, Section 7, Question 1. Haha, the last section! Not only is it the last section, but this is the section where we learn about imaginary and complex numbers. Ooh. Alright, so in good news, you actually already know almost everything there is to know about imaginary and complex numbers. For example, what is the square root of 4? The square root of 4 is 2. So what is the square root of negative 4? It is not a real number. So what we do is this negative becomes I for imaginary. That's it. That's what we're learning. That's the big secret. Sorry, very anticlimactic. Do you remember from back in chapter 1 that PPCC is looking for with parentheses, without parentheses, and then adding and subtracting? These parentheses can just go away and you'll get 7 plus, hey, 2i plus negative 5 minus, hey, the square root of 9 is 3, so the square root of negative 9 is 3i. It has no parentheses. Ta-da! Then, combine like terms. Now be very careful. We have to write these in the form of a plus bi. So the nice numbers go first, and then the I thingies go second, and we get minus I. Done. So the i's have to come second. So a plus bi, that's done. Here, again, the square root of 20. Hopefully by this time, you are able to look at the square root of 20 and say, hey, that breaks up as 4 and 5, so that is 2 square root of 5. Hopefully you can look at the square root of 12 and say that's 4 times 3, so that is 2 square root of 3. But wait, what happens with this negative? The negative becomes an I. So this negative becomes an I, and it lives right there. This is an A plus BI form. Nice number first, I thingy second. Here we're going to have to distribute this negative. Remember, we've been distributing the negative, and many people have been having problems with that since chapter 1. It especially got a lot of people in chapter 6. So this is going to be negative. Hopefully you remember 45 is 9 times 5. 9 is going to make it into 3 square root of 5. Negative times positive is negative. 75 is 25 times 3, so that is 5 square root of 3. But what happens to the negative on the inside? It comes outside as the letter I. Again, A plus BI form. The nice numbers go with the nice numbers. They're like terms. They both have square root of 5s. So we get negative square root of 5. If you want to put a negative 1 square root of 5, that's fine too. And then the I square root of 3s with the I square root of 3s gives me negative 7i square root of 3. That is done. So take a look. With parentheses, without parentheses, then add and subtract. With parentheses, without parentheses, add and subtract. As we're getting to the without parentheses, that would be an appropriate time to simplify radical form. We do still have to do simplified radical form from earlier this chapter. Chapter 7, Section 7, Question 2. A quick pre-teaching. If I have the square root of negative 1, we use that to equal I. That's what we were doing on the last slide. If I square both sides, the square and the square root will cancel, so I squared is equal to negative 1. Folks, these are important things to know, that I is equal to the square root of negative 1, that is by definition, and by squaring both sides, you get I squared is equal to the negative 1. This is something we absolutely need to know. We are going to build on it later on this section. So here, when you're doing this, many students say, hey, I recognize that, that's a distributive property. But before you do the distributive property, you have to do simplified radical form. Now, the important thing is to bring this out as an I. That's the key part. So if you want to simplify radical form later on, you actually could. But this is going to become an I on the outside with a square root of 5. You will never have an I on the inside. You will never have an I on the inside of the radical. And then we could actually simplify that. That's 4 times 5, which is 2 square root of 5, minus 12. That is 4 times 3, so 2 square root of 3. What happens to this negative on the inside? It comes out as an I. Then we're going to use the distributive property. I times 2 on the outside gives you 2i. The 5 and the 5 on the inside pops out as a 5. Here, we will get 2i squared. Hey, I squared is going to be a thing. Inside things times inside things gives us a square root of 15. Now what was I squared? I squared was negative 1. So what's a negative 2 and a negative 1? That will give you a positive 2 square root of 15. And 2 times 5 gives you 10i. And you might think you are done, but remember a plus bi form. The thing with the I has to go in the second spot. Regular thing, I thing. Regular thing, I thing. Hey, the 2 square root of 15 has to come first. The 10i has to come second, or it's wrong. Hey, that's foiling. In good news, these already have their eyes. This has its eyes. That's what tells you you can start multiplying. So be very careful about that. Here, we're going to FOIL that out. We're going to get 20 plus 50, I minus 6, I minus 15, I squared. Ah, but what is I squared? I squared is negative 1. Ooh. Now, I only do this because I saw one of the college professors doing this. Negative 15 I squared. That's actually a plus 15. Now, if that's going to get you confused, please just use an extra line of work. But some students are looking for ways to shorten their work. Since I saw one of the college professors doing that, I am actually accepting that. So here, we're going to combine it. Remember, the nice numbers are going first. That's going to give us 35. And then the I thingies come second, plus 44i. A plus bi form, looking good. Chapter 7, Section 7, Question 3. Dividing complex numbers. This number is not in simplified radical form. Why not? I don't see a square root in the denominator, but remember that I is the square root of negative 1. There is a square root in the denominator. How do we fix square roots in the denominator? From 2 sections ago, we use the conjugate. So here we have 2 minus 5i. The conjugate is going to be 2 plus 5i. Look at all these parentheses to make sure that we are multiplying everything out correctly. And we're going to FOIL on the top. We're going to FOIL it on the bottom. We're going to remember that I is the square root of negative 1, and I squared is negative 1. We're going to build on this in the future, very soon now. FOILing on the top, we get 14 plus 35, I plus 6i plus 15, I squared. Hey, I squared is going to be something else. Neato, 4 minus, no, plus 10i minus 10i minus 25. I squared is going to give us a thing. Now, if you're okay with the fact that I squared is negative 1, a plus 15 times I squared will make this into a minus 15, and a minus 25 times I squared will make this into a plus 25. If that is confusing to you, just have an extra line worth of work. Combining like terms, 14 minus 15 is negative 1. 35i plus 6i gives you plus 41i all over. These cancel. 4 plus 25 gives you 29. If we were in 7.5, we would be done. But we are now in Chapter 7, Section 7, where we have to write these as complex numbers. Complex numbers are a plus bi. If you remember, back in Chapter 5, Section 3, we made 2 little fractions and reduced. In this case, these numbers are so yucky, they do not reduce. But you do have to have them in a plus bi form. So be careful about that. So this answer here, which would have worked in a previous section, does not work now because it has to be in a plus bi form. Interesting thing, if you know how to type this into your calculator and use math enter, it will actually give you the answer. How much credit am I going to give you without all of this work? Probably nothing. So please make sure you show the work, but if you see this on a calculator test if you see it on your SAT or your Accuplacer sign and you're allowed to use your graphing calculator, there's a way to get this and just hit math enter and get that. You should try it to make sure you have that skill on your graphing calculator because it is really awesome and will save you a lot of time on your SAT. Take 3,687. So, Chapter 7, Section 7, Question 4. If you want to find problems like this in your textbook, look at problems 97 to 104. In Chapter 7, Section 7, this is about I to the really big power. Are my I powers a lot larger than in the book? You betcha. Why? Because I can, and because I'm going to teach you how to handle an I to the any size power and get the answer very quickly. Simplify these, and I'm going to show you how to do it in 4 steps. Note, review the pattern and division rules for 4. So, we're going to start off with I. I is I. What is I squared? Ms. Jordan, from previous problems, we know I squared is equal to -1. That is a very useful fact to have memorized. What is I to the 3rd power? That's I times I squared is I to the 3rd. Therefore, I times -1 gives me -I, the answer to I to the 3rd power. What is I to the 4th power? That is I squared times I squared is I to the 4th, so -1 times -1 is +1. But wait, there's more. What's I to the 5th power? I to the 5th power is I to the 4th power times I, which is 1 times I, which is I. But wait, what if you said I to the 5th power? Couldn't you also get it by doing I squared times I cubed? Yes, you can. So if I multiply this side, shouldn't I still get I? I do, because math works. That's a wonderful thing. I to the 6th power is I to the 4th and I squared, which is -1. I to the 7th power is I to the 4th and I to the 3rd, which is -I. I to the 8th power is I to the 4th and I to the 4th, which is 1 times 1, which is 1. Do you see a pattern? Because math is all about patterns. I, -1, -I, +1. I, -1, -I, +1. There's a pattern there. You're going to see this kind of a pattern in a lot of different things. Every 4, it repeats. On your SATs, your ACTs, your Accuplacer, your GREs, you're going to probably find that you will have patterns of different lengths. Sometimes it will repeat every 4, every 3, every 5, something like that. But here it repeats every 4, which means once you know this set, you're set. So let's take a look at this. I just need it to be a multiple of 4, and the answer is 1. These are not all multiples of 4. I know that because some of them have odd numbers. They're not multiples of 4. But if I had I to the 4th, I to the 8th, I to the 16th, I to the 40th, I to the 400th, I to the 444. All of those are multiples of 4, and I to the large number that is a multiple of 4 will give me 1. That is a cool thing. So, what I need to look at this is I want to take out a lot of multiples of 4 because that's going to make my entire life easier. What I can do is I can just look at the last 2 digits to see if it is divisible by 4. Now, why is that? That is because 100 divides nicely by 4. So does 700. 1,000 divides nicely by 4, which means so does 6,000, etc. So this could be summarized as I to the 54th power. How many times does 4 go nicely into 54? Let's see. 54 divided by 4 goes in there. 1 times 4. Subtracting. 3 times. 3 times 4 is 12. There is a remainder of 2. I just took out 13 sets of 4 with 2 remaining. These 2 remaining are what is going to determine what the answer is, because all of those 13 sets of 4 i's, they all became 1s because I to the 4th is 1. So I squared is all that's left. But what was I squared? Miss Jordan, an awesome thing to memorize is that I squared is equal to -1. So the answer is -1. Let's take a look at the steps. Step 1, I to the 2-digit power. Step 2, divide by 4. Step 3, take the remainder. Many students get this wrong because they'll take the 13 and put I to the 13th. That doesn't help you. We want this remainder, I squared, and then what is I squared? I squared is -1. Step 1, 2, 3, 4. That's how it's done. Let's take a look at this one. Step 1, I to the 23rd power. Step 2, 23 divided by 4. It goes in there 5 times. 5 times 4 is 20. We subtract that and get 3 remaining. Step 3, I to the 3rd power. What is I to the 3rd power? It is -I. Notice that we are using lowercase i's for imaginary. It's a thing. You do have to have a lowercase I. If you use an uppercase I, it's actually not going to work. Step 1, we're going to make I to the 85th power. Step 2, we're going to 85 divided by 4. 2 times 4 is 8, subtracting. We get a 5 here. Goes in there once. 1 times 4 is 4. 1. There is 1 remaining. That is I to the 1st power. And you can check here, what's I to the 1st power? It's I. But wait, think back to chapter 1. What happens when you have an exponent of 1? 3 to the 1 is just 3. I to the 1 is just I. Math works. The rules that we learned back in chapter 1 still apply here. Something to the 1st power is itself. I to the 1st power is just I. Step 1, I to the 76th power. Step 2, 76 divided by 4. 4 goes in there, and 1 times 4 is 4. 3, 6, 9. 9 times 4 is 36. 0 left over. I to the 0th power. Wait, Miss Jordan, we don't have an I to the 0th power. What am I supposed to do? Well, 8, 7, 6, 5, 4, 3, 2, 1. Okay, there's I to the 1st. If I kept going, the next one would be I to the 0. Let's look at the pattern. 1, -I, -1, I. 1, -I, -1, I. 1. This is 1. Oh, the answer here is 1. But let's think back to the fact that we already know that I to the 0th power was 1 from back in chapter 1. Let's review that. What is x to the 3rd divided by x to the 3rd? With exponents and combining exponents, it says to divide, but you really subtract, and you get x to the 0th power. But something divided by itself is 1, unless x was equal to 0, in which case that would be bad, because dividing by 0 is bad, so x cannot equal 0. But otherwise, something to the 0 equals 1. Even with imaginary numbers, this still holds true. That is how we're going to do this, which means this does not matter how long it is. You don't have to divide 4 into this whole number here, just the last 2 digits. That's enough to tell you what the answer is. Chapter 7, Section 7, Question 5, Type 1 of 2. Yay! You might remember from back in Chapter 1, Section 3, that we learned about the additive inverse and the multiplicative inverse. Those were the days when +5 became -5 and became the opposite sign. The multiplicative inverse where 5 became 1 over 5, the reciprocal. And you might think, oh, this isn't a bad question. And you'd probably be wrong. So we're taking -7 plus 6i. -7 plus 6i. The additive inverse, 5 becomes -5, -7 becomes +7. +6i becomes -6i, and this part is done. Folks, you can get a half credit very nicely, just knowing that the additive inverse means you change the signs. Woot! But then, we look at the multiplicative inverse. We are finding the reciprocal. So if we take -7 plus 6i and find the reciprocal, we will get 1 over -7 plus 6i, and we would say, we feel so accomplished. But we can't leave it like that because of simplified radical form, which is a theme for all of chapter 7. This is what we've been trying to teach you, is simplified radical form. But wait, where are the radicals? I don't see a radical. Do you remember that I is the square root of -1? There is a radical hiding there. How do we get rid of it? We have to use the conjugate. What was the conjugate again? The conjugate was change the middle sign. Many students want to change the sign in the front because they feel very uncomfortable with the leading negative. But you have to change the middle sign. And the thing is right now we are changing the middle sign of the denominator. There was a question in 121 where you'll have to change the middle sign of the numerator. It will be rotten. But hey, that's next year. This is this year. Foiling out the bottom, we get 49. We get plus 42i. We get minus 42i. We get minus 36i squared. We are extending this vinculum out. Remember, I squared is -1, so this is actually a plus 36. These cancel, and we get -7 minus 6i over 85. And you might think, yay, I am done. But you'd still be wrong, because dang it, this is a complex number. And remember how in chapter 5, section 3, we made little fractions and reduced? Hey, we're going to still make little fractions. And if you can reduce, you're going to reduce. In this case, you can't reduce. Yay! That is finally your answer. If you could reduce, darn it, you'd have to reduce. But we have calculators, and at some point, we're going to have to deal with things like the SATs, the Accuplacers, and someday maybe the GREs. Those are coming, and some of those allow you to use calculators. So, you could type in 1 divided by parentheses -7 plus 6i, end parentheses. By the way, where is this I in your calculator? The I in your calculator is on the bottom, right above the decimal, so you have to hit second and then the decimal to get that. And then you hit math, enter, enter, and I'll give it back to you like this. Be very careful. If you have the older operating system, what it will look like is -7 over 85 minus 6 over 85i. And many people think, oh my goodness, the I just went onto the denominator. But that's not correct, because order of operations says this is a fraction, and then you times it by I. So the I is actually on the top, and a lot of students get confused about that. So be very careful. This is also one of the reasons why I don't like the diagonal vinculum, is the number of students who don't understand what it's saying or suddenly start writing things incorrectly. But Chapter 7, Section 7, Question 5, Type 2 of 2. This is it. This is as hard as it gets. So, here we go. You might notice that this looks remarkably similar to Chapter 3, Chapter 5, Chapter 6. We're plugging things in. How amazingly wonderful is that? So we have the formula here. We're going to plug in 3 minus 2i. Anywhere you used to see an x will now become a 3 minus 2i. Question on the left-hand side on every single line. 3x squared minus 2 times x plus 4. I have actually had a hard time with learning this, so I put these parentheses so I have a landing pad to put my 3 minus 2i, because sometimes I'll write it incorrectly. Hey, that's plug. I need plug, work, and answer. Sometimes it's going to be easier if you have your plug and then your work. Remember over here, you can't just square this and square that, only if it was being multiplied inside, but because of the adding and subtracting, we actually have to FOIL it out. And remember, we cannot multiply 3 things at the same time. It might be worth it to make this problem longer so that you can actually get it all correct. This is not a very nice problem. I'm going to multiply the yuckier 2. If you remember in Chapter 5, Section 2, I said multiply the yuckier 2 first. combine like terms, and then multiply by 3. If you had to do it on the side, that's fine. You get 9 minus 6 and minus 6 gives you minus 12i plus 4i squared. And then we get to distribute. We get 27 minus 36i. You might actually take a moment and make this into negative 4 and make negative 12. Distributive property here as well. Negative 6 plus 4i plus 4. Oh my, look at all those terms. We need to put together 27 minus 12 minus 6 plus 4. I got 13. Did you get 13? 15, 9. Okay. And then we need to put together our i's, their other i's. And I got negative 32i. This is an a plus bi form. Remember, the order matters. And that is how we do it. Plug, work, and answer. Hey folks, that is a lot of work. But if you need only one line of work, I'm thinking this line is the one I really need to see. Because going from here straight to here, I don't think that's happening. So, hey, show me enough work so that here, I need to see that you got to this step so that you can get to this step. So if you want to cut something out, yeah, you're going to cut out these guys. So make sure that you get to this just right before you can add and subtract.